Hi everyone. So in today's video we're gonna try to find the Laplace transform of cosine of beta t, right? Now we know that the Laplace transform of a function f of t, this is equal to the integral from 0 to infinity of the function f of t times e to the power minus st dt, right? So this is the definition of Laplace transform. So in our case, the Laplace transform of cosine of beta t, this would be the integral from 0 to infinity of e to the power minus st times the cosine of beta t dt. So this would be our integral. Now to solve this integral, let's concentrate first on the indefinite integral, right? So we're gonna focus on the indefinite integral, which would be integral of e to the power minus st times cosine of beta t dt. Now to solve this integral, we're gonna use the integration by part technique. So we're gonna let u, because it is a product of an exponential function and a trigonometric function, so we're gonna let u be equal to the trigonometric function, right? So we let u be cos of beta t and dv be equal to e to the power minus st. Now this implies that du, which is the first derivative of cosine of beta t, this would be minus beta sine of beta t, right? Because the derivative of cosine of beta t would be minus sine of beta t, and then we need to multiply by the constant beta. So this would be the derivative of cosine of beta t. Now to find v here, we need to integrate, right, e to the power minus st. So v would be e to the power minus st, and then we divide by the constant, that would be s in this case, right? So now the integration, our integration here would be equal to uv minus integral of v du. So that would give me uv, so cosine of beta t times e to the power minus st over minus s. So u times v, and then minus integral of v du, right? So we have v, which is e to the power minus st over minus s, and then du, which is this, so we gonna multiply them, and that would give me e to the power minus st over minus s times minus beta sine of beta t, and that is with respect to t. Now this would be equal to the first part. We can write it down with the minus that's gonna come on the top here, right? And then here we're gonna take beta and minus s out, so we're gonna have minus integral minus beta over s, and then we have the integral of e to the power minus st times sine of beta t dt. So this integral here is equal to this. Now we can see that we have an exponential and a trigonometric function again, so we're going to use the same technique to try to integrate it, right? So in this case, we're going to let u be equal to sine of beta t, right? So u is equal to sine of beta t, and then dv is the same e to the power minus st, right? Now du here, we're gonna differentiate sine of beta t. So du would be beta cosine of beta t, because derivative of sine is cos. And then we're gonna integrate here. So v, if we integrate this, would be e to the power minus st over the same constant minus s. We're gonna do the same, uv minus integral of v du. So this would give me that the integral of e to the power minus st times sine of beta t dt, that would be uv. So we got this times this minus integral of v du, right? Same thing. So we're gonna have uv, which is sine of beta t, times e to the power minus st over minus s minus integral of v du. So our v is e to the power minus st over minus s times du, which is gonna be beta, and we have cosine of beta t, and that is dt with respect to t, right? So this integral here is equal to this. So this means that what we got here, it would be, we can copy it down here, it would be this thing here with the minus here, and then the integration, basically we can substitute what we have just found, right, for the integration. So that would be sine of beta t, this thing here. So that would be the sine, we can put it here up front. So we have sine of beta t e to the power minus st over s, and then we take here beta and s and minus s out, so that would give me plus beta over s, then we have integral of e to the power minus st times cosine of beta t dt. So right, now we can expand this. So we're gonna multiply this here by this, and then this by this, right? So let's expand this equality. So the first bit would be the same, we can duplicate. Now the second part would be minus. If we multiply this, we're gonna have minus times minus would be plus, and then we have on the numerator beta times sine of beta t e to the power minus st. On the denominator we have s squared, and then if we multiply this one by this one here, that would give me minus beta square over s square times the integral of e to the power minus st times cosine of beta t dt. Right, now we can see that we started from this, and by doing integration by part we ended up having the same thing, right? So this would mean that if we keep repeating this process, we would be in the cycle of sines and cosines. So we would need to use a technique that's gonna help us find our integration. So we would define I is defined to be the integration that we want to find, right? So this is I. Let's put it in blue. Now what we're gonna do is we're gonna substitute I by what we got. So we're gonna make the equality and then we're gonna substitute this by I, right? So what we're gonna get is I, which is the first one here, is equal to this last one that we got here. Let's duplicate it. So I is equal to this, but this part here we're gonna substitute it by I, because we said that I is defined to be the integration of e to the power minus st times cosine of beta t, right? So this one here we're gonna let it be I, right? Now we need to make I the subject of this formula, and that would give us our integration that we want to find. So this implies that I plus beta square over s square I is equal to this here. Right. So from this, if we factorize, we take I out, that would give me 1 plus beta square over s square, that is equal to, here we make the denominator being s, so on the numerator we're gonna have s times this numerator, right? So we're gonna have minus s times this, and then we have here plus beta times sine of beta t e to the power minus st, right? Now what we're gonna do is here to make s square the denominator, so I times s square, on the numerator we have s square plus beta square, and that is equal to, here we're gonna take e to the power minus s out, so we're gonna factorize the numerator, so e to the power minus s out of the bracket, and that would give me here minus s times the cosine of beta t, and then plus beta times the sine of beta t. On the numerator we have s square, right? Now here our goal is to find I, so we're gonna divide both sides by this, right? And dividing is basically multiplying by the inverse. So basically I, if we flip this one here, s square and s square are gonna cancel out, and this is gonna go on the denominator, right? So I, the integration we want, is equal to the numerator here over this one here, s square plus beta square, right? So this is our, so I, we said that it is the integration we want. So the integration we want, this is equal to what we got here. Right. So this is the indefinite integral, right? But what we want it to find at the beginning is this definite integral that goes from 0 to infinity, right? So this was our goal. So this would be what we have found here, and we put this bracket 0 to infinity, right? And now what we're gonna do is just substitute the infinity minus when we substitute the 0. So first we're gonna substitute the infinity here in this fraction here. So if we substitute this infinity into the t, we're gonna see that we have e to the power minus infinity, which is 0, right? So this is basically equal to 0 minus, and then if you substitute 0 inside, so you're gonna have e to the power, we're gonna have e to the power minus s times 0, right? And then minus s times cosine of 0 plus beta times sine of 0, and then over s squared plus beta squared, right? Now this is equal to, we can see that e to the power 0 would give me 1, right? So here we have a 1 times, inside here sine of 0 is gonna cancel out, so basically here this is gonna go away, and then here cosine of 0 is 1, and here we have a 1, so basically this is equal to 0 minus, so we have minus up front here, and then we have on the numerator 1 times minus s times 1 plus 0, right? And then we have s squared plus beta squared, right? Now this minus would make this positive, so this is equal to, s over s squared plus beta squared, and that is our final answer. So in conclusion, the Laplace transform of cosine of beta t, this is equal to s over s squared plus beta squared.